Good evening. My name is Markus Rex, and I must admit I am absolutely overwhelmed. The 9 last months I spent in the Arctic ice, surrounded by a small team of people only, and I'm not used to see so many people and everyone hidden behind a mask, which is something we did not have in the Arctic. I hope you bear with me for these feelings. I had the atmospheric research at a research institute, and I'm a professor at Potsdam University, and I'm a head of the biggest Arctic research mission of our times, which just ended 10 days ago. With this expedition that my speech is going to be all about, we have explored the limits and pushed the limits of the doable. We have broken the limits of Arctic research. For the first time, a modern icebreaker was brought into the direct proximity of the North Pole in the winter half year. This is a season in which it did not used to be possible, and from which we were excluded in the 3 Arctic regions near the pole until now. We've really pushed the envelope for signs of the Arctic climate system will see a great impact through this. We did this through a wonderful interdisciplinary international research mission. 20 nations gathered to enable this mission to be carried out. 90 institutions were represented from the 20 nations, and from all these institutions, researchers from different countries came together. So 37 countries were represented. So it's a truly fascinating international atmosphere, which was absolutely inspiring, very interdisciplinary. From all the areas of the Earth system research, we collaborated. 7 icebreakers were used to support the operation of a central flagship, which was frozen in the ice. And to enable year-round research with an icebreaker in the Arctic, 450 people were active throughout the year during the different phases of research, including staff of our ship and also the staff of the ship that came to support the Polarstern ship. So this really was a large-scale activity and a large-scale mission, which cost quite a lot of money. 145 million euros was the overall budget for the mission. And one mission statement united all the nations that gathered for the operation, even though they hold a contrary geopolitical interests in the Arctic. But we were united by saying that we wanted to better research the climate-relevant processes in the Arctic. We all had this one objective, which is why the different opinions and politics that the nations hold did not play a role at all. This was fascinating in itself. If one goal unites you, then you can collaborate and work together and be successful. I was very happy with that. I wanted to start out showing you a small video showing you this overall expedition and summing it up.
The Arctic. No other region on our planet is warming as rapidly. But how does the Arctic influence the global climate? It's the largest Arctic expedition in history with a common goal: to collect data over an entire year in order to help find the missing piece of the puzzle in climate research. Polarstern set sail from Norway bound for the Arctic, supported by the Russian research vessel Academic Fedorov. Her goal, to find a suitable ice floe. At 85 degrees north and 134 degrees east, Polarstern allows herself to become frozen in the ice, and the drift begins. It's a race against the oncoming polar night. The camp is set up in just 18 days. From now on, the interdisciplinary teams will collect valuable data every day. Storms and extreme temperatures make research challenging and alter the appearance of the floe. The constant worry on everyone's minds: will the floe remain stable? An international fleet supports the team on this extreme voyage. The first exchange of crew and supplies takes place in the middle of the polar night. Meanwhile, on some days, Polarstern drifts up to 25 kilometers. Once again, Kapitan Dranitsin sets off on a supply mission through the sea ice, which is delayed by difficult weather and ice conditions. A new record in the meantime. Never before has a research icebreaker sailed so close to the North Pole in winter. Kapitan Dranitsin, on the other hand, only comes to within 970 meters of the camp on her resupply mission. The equipment has to be hauled across the ice. Afterwards, Kapitan Dranitsin has to battle her way back through the thickening ice. Her return journey to Norway is only possible with additional refueling by Admiral Makarov. The corona pandemic poses unforeseen challenges. The scheduled crew exchange hangs in the balance. Polarstern has to temporarily leave the floe. Her new interim destination, Svalbard. There, in a historic rendezvous, the German research vessels Sonne and Maria S. Merian meet with Polarstern to exchange crew and equipment, and then the expedition can continue. The summer ice melt begins. Despite this, the floe and camp remain intact. The expedition accompanies the mosaic floe to the end, until it completes its life cycle and begins breaking up. Meanwhile, Academic Tryoshnikov reaches Polarstern for the final crew and equipment exchange. Thanks to unusually large stretches of open water, Polarstern reaches the North Pole in just 6 days. Here, the experts will investigate the final piece of the puzzle, the formation of new ice. Finally, the expedition ends with a warm welcome in Bremerhaven. For an entire year, the research teams have worked day and night to ensure that the complex interactions between the atmosphere, ice, ocean, and ecosystem can be modelled more accurately for decisions on urgently needed climate protection measures.
So again, Captain Dranitsin starts on his support mission through the ice, delayed by difficult weather and ice conditions. In the meantime, this is a record that broke. Never before a research icebreaker had been so close to the North Pole before. Captain Dranitsin can only come as close as 970 meters to the ice camp. The equipment has to be dragged over the ice, after which Captain Dranitsin fights his way through the thickening ice back to the ocean. Only Admiral Makarov's support with fuel enables the ship to travel on. Unexpected challenges come with the COVID-19 pandemic. Polarstern has to leave the floe temporarily. The next harbor is Spitsbergen, where the German research vessels meet to support Polarstern. And finally, the expedition can be continued. The summer's ice melting process starts. Still, the floe and the camp remain intact. Until the very last day, the expedition supports the mosaic floe until it is completed its mission and breaks. Meanwhile, the support vessel comes to supply the Polarstern once more. Unusually open ocean parts lead the Polarstern to the North Pole in only 6 days, where it further continues to explore the ice. With a big welcome, the expedition ends in Bremerhaven, Germany. A full year, research teams work day and night in order to find out about the complex interactions between the atmosphere, the ice, the oceans, and the ecosystems, and to show these in climate models. in order for climate-relating political decisions to be able to be made. All right, wonderful. So I would like to ask you, if you have any questions during my presentation, please give me a show of hands. At least this holds true for all those present. And I would like to say hello to everyone who's joined us on the live stream. For you, there will be a chance to post your questions following my slides. We have 2 microphones here in the room, and there's colored dots, spots on the ground. You can stand there and speak into the microphone, but please wear your face masks because we need to make sure that we do not spread the virus in here. Okay, so let's come back to the question of why we did all this. This was a major international effort to be able to do it in the first place. We do it because the Arctic is the epicenter of climate change. No other place in this climate warms up as quickly and as rapidly as the Arctic. We can see this from very simple parameters. If we take a look at this change in surface temperature of our planet since the 1970s until today, then the red colors show us a very steep increase in temperature, and the white and blue colors show us no warming or even a cooling. But up here in the Arctic, warming is by far the most pronounced one. At the middle of this year, we had a warming of 2 degrees Celsius during this year, which was actually way beyond the limit we had foreseen for the whole Earth. In the Arctic, we've already exceeded that limit of 2 degrees. And in winter, the warming is even more pronounced than we can see here on the chart. This is actually totally dramatic. And warming in the Arctic already today is clearly to be seen. Since the beginning of the 90s, I've traveled to the Arctic regularly. These are pictures from March, which is still winter time in the Arctic. It's always the same station near Spitsbergen, near a fjord. And when I would go there in the 80s, then all we would find there was would be ice and snow. These blue ice mountains frozen in the ice on the fjord. So you see a frozen fjord here, and we would use our skis to travel along the fjord. When I go here today, then on the right-hand side is a picture from 2018, from the same time of the year. The fjord has not been frozen for a decade, with one exception, which was the last year with a bit of ice. We have open waters where we used to use skis, and we now use boats where it used to be so easy to travel the ice with other vehicles. So in the Arctic, all you need to do to see climate change is look out the window, and that influences the life of people, especially of indigenous peoples living in the Arctic, and they see that on a daily basis. Over here, climate change happens in the newspapers mainly, and some seem to be observing that some summers are hot, but there were hot summers in the past, and whether climate change is there at all is an absurd question for people living there in the Arctic. At the same time, the Arctic sea ice disappears with global warming. On the left-hand side, we see the extent in million square kilometers, which part of the Arctic at the end of the summer is covered in sea ice, because the Arctic is a deep ocean, 4,000 meters deep in most spots, which is just covered by a thin layer of ice, just 1 to 2 meters thick as a general rule. So this ice cover has molten from more than 8 million square kilometers in the 1960s to 1970s down to less than 4 million square kilometers. And we can see this on the chart on the right-hand side, what that means. This is the whole Arctic area that used to be covered in ice at the end of the summer, but that's open sea today, and the ice has withdrawn. We can follow this curve with our eyes. If you want to extend that curve, then it'll take just a couple of decades more until we get to zero. So if this development goes on as forecasted, then in a couple of decades' time in summer, we will have a completely ice-free Arctic. It's going to be a different world. It'll change the whole shape of our planet, because if we used to look at the Earth from space, then where we used to see a white cap on the North Pole, we would see a dark spot, and that will influence the climate on the rest of the planet also, of course. And you might as well start in Hamburg sailing to the North Pole with a sailing yacht. It would be no problem at all. So this is a development that comes ahead of us, and we only have a very short time window if we want to stop this. So if this development goes on, we will be the last generation to have seen a year-round ice-covered Arctic. When I stood there on the ice in the Arctic, and I thought that my children would not be able to see this with their own eyes or live it in their lifetimes, and that was a truly impressive memory to take away. It has an impact for the climate in the rest of the world. This is the climate kitchen for Europe, for Asia, for North America, and the contrast in temperature between the cold Arctic up here and the warmer regions down there drives the west wind jet stream, which plays a major role in our weather impact. It impacts our weather systems, and once this temperature contrast is less pronounced because the Arctic warms up more quickly than the rest of the world, and that makes for a less pronounced contrast, then this jet stream temperature dynamic will cause waves that can be stationary, and that can mean that heat comes from the subtropics into the Arctic and the warm air will pass us, which will lead to very hot dry spells in summer and more intense extreme phases, but also cold air outbreaks can come down into our latitudes from the Arctic, and we will get blizzards in wintertime that will come down to Florida. And this is also something we've seen in the last years. Also with some cold phases with our winters here in Europe that we used to see in the second half of winter, and that get more intense. And then we wonder, well, climate warming, global warming, when it's so cold out my doorstep. It doesn't seem to be evident, but this is a consequence from climate change, which also can cause cold spells in summer.
The Arctic also is the region of the world where we know least about the climate system. This is the climate projection of more than a dozen climate models that there are in the world, and these are the basis for our political decisions in the world. We ask our climate models what happens to our climate if we emit amount X of CO2 or if we lower it or restrict it. We need the climate models, and there is a range of uncertainty, and the results are always a little different. And what you see here is the warming from today onwards until the end of the century in Antarctica, the tropics, and the Arctic. And it shows the range of the climate models. And the uncertainty is bigger in the Arctic because we have to improve our models there. If we have take the negative greenhouse gas scenario, which we see here, and there are models that show 5 degrees Celsius of increase, and other models forecast a 15 degrees Celsius of temperature increase. These are huge numbers. The Arctic is warming up dramatically, but this is a very negative scenario. But there's an uncertainty factor of 3. So this, as such, should be improved in order for us to have a solid foundation for decision making. And what is the background? Where does this uncertainty come from with regard to the Arctic as compared to other regions of the world? The background is that many processes in the Arctic climate system are only roughly represented in climate models. And the reason for this is that many of these processes have never been able to be observed the whole year through. In winter, the ice of the Arctic is so thick that we can't get into the Arctic with the icebreakers. We are always excluded, and this is why we are lacking fundamental data of the North Pole for the winter season. But the climate models have to calculate anyway. They have no choice, and this is why they come up with ad hoc assumptions about the processes. So this is basically guessing, because if you don't have data, you have to guess, and the model guesses differently from the next, and this is why we have this range in order to come up with real observations. So how are we doing this? If we want to get into the Central Arctic, as I said, you can't get in there because of the thickness of the ice. We can't try to ram the ice as much as we want to. With Polarstern, we can't get into, but a very savvy person showed it to us in the last century, so in the 19th century. He learned from a shipwreck which was enclosed in the ice, the Jeannette vessel. It was it crashed there, and the crew died. So he had heard reports that remnants of this vessel were found off Greenland, and people didn't want to believe that, but he believed in it. And he also found wood of Siberian trees that were found there. He came up with the conclusion that there is this route, so to speak, to Greenland from the Arctic. And if this can happen with a shipwreck, this can also be done with a functional vessel. So he had a ship be constructed in a shape that it was lifted from the ice if under pressure, instead of being smashed by the ice. This is his sailing ship with which he was in the ice. He used the ice. He had the vessel be frozen into the ice, and he drifted for 3 years with the ice, and they all came back safely and healthily, and he penetrated and he traveled further than anyone else before. And we did similar things, because we cannot get into the ice. You have to use nature, work with it, instead of trying to work against nature. And to be naive, thinking that you could overcome and win over nature. No, nature is reigning over there. Nature is the master there, and so you have to use it and work with it. This is exactly what we did. We started in 2019 in September. We passed open waters until we reached the edge of the ice, and we allowed for our vessel to be frozen into there. Now you see the basic concept of our expedition. We built a huge research camp around Polarstern because we wanted to carry out large-scale research. With a research camp, it was a kind of small town or city next to our Polarstern, and 50 kilometers away we erected stations with autonomous measurement sensors, devices that we visited on a regular basis with our helicopters. So we established a full network 50 kilometers away, and our research camp next to Polarstern, and we all drifted through the Arctic. And as the ice expands in winter and is reduced in size in summer, we followed the ice, as did Fridtjof Nansen at the time. At the beginning, the ice was thin enough, and at the end it was thin enough again. We were supplied by our partner icebreakers. We needed bunker supplies, we needed other supplies, and the expedition team was also replaced several times. So we had 6 additional partnerships and icebreakers, and research aircrafts and helicopters supported us in order to be able to embed the local measurements into the Arctic-wide system of climate processes. This is the underlying idea, the basic concept of our expedition, and now I'm going to explain to you how we proceeded. Of course, you have to adapt the expedition time and time again. As you are in nature, you can never implement it in the way you originally planned for. Here you see the changes. This was the original planning, the 20th of September it started, it ended on the 12th of October, and every gray box is a month. In the Arctic, for half a year, there is the polar night, no sun rising, and if you see the sun, it's so low that it gets dark again right away, and there was a day and night change, and the period was even shorter than it's shown here, and then polar day for half a year. So the sun is rising and rising and rising until midsummer, and then it migrates around the horizon and then goes back down to the horizon, goes down fully, and the polar night starts again. This is the variation of light there. During the expedition, we had 6 different phases of planning, and in between, we were supplied by our partner icebreakers. At the beginning, we went together with the academic Fedorov. We traveled together for 6 weeks. And then in mid-December, Tranitsin, and then in February again, this was a Russian icebreaker which was supposed to supply us. This is the stage where the ice is so thick that the icebreaker can't get through. So an ice runway was supposed to be built, and it was built, to exchange the expedition team to replace it with the special type of aircraft. And in June and July, we were supplied again with our partner icebreakers. At least that was the concept. And this is how we started. You see the ice conditions. Could you switch and change the slides? It doesn't, from the back, it doesn't really seem to work very well if I do it. I'll let you know when you change the slide, please. So these are the initial ice situations at the beginning of our expedition. The extension of the ice at the end of the summer 2019. This is Tromsø. This is our target region where we wanted to be frozen into the ice. Next slide, please. And it worked very well. In summer 2019, the ice retracted. We went through the Barents Sea free from ice up here to the north. In the Leptev Sea, that was the first time where we hit ice on September 25th. That was our first contact with the ice. 1.5 hours later, can you please 2 times changing the slides, so that we saw first polar bear. We saw many polar bears until the end of our expedition. On September 29th, we reached our target region, and our first task was to find an ice floe we could erect our research camp on. And this is where we were still traveled together. This is the academic Fedorov, the partner icebreaker. We had more space because we were 2 vessels next to each other. And we used this opportunity to have young scientists on board who are at the beginning of their career. We were able to include them so as to train the next generation of scientists when it comes to planning and executing such an expedition. There was enough space on the Fedorov. There were more than 200 applications for spaces in that mosaic training situation. We had selected around 20, and they were with us during this expedition. Let me show you a short video. So this shows very nicely how the first 6 weeks of the expedition took place, when we still had a lot of water, a lot of daylight, and it shows that our students had way too much fun during this expedition. But it's also very characteristic. If you're together on the ice, you grow together as a team, and you need to have some fun because there's a lot of performance that is expected from you on a daily basis. When we reached the target region, the destination, we split so as to be able to research and explore a larger region. This is the Fedorov region. They were looking for an ice floe, and we were looking here. The yellow dots or circles, these are ice floes that we looked into very thoroughly. And we were disappointed because the easiest thing to do is to drill a hole in an ice floe to check the ice quality. And we had 60 and 70 centimeters ice on average, which is not a good result per se. We would have needed more than a meter right away. And out of the 60 to 70 centimeters, if you have a look at an ice block, you've got two of the extracts or the drill results. This is the low part of the ice. It's fully eroded, melted with holes because it already had melted so much. So we only have had 30 to 40 centimeters of solid ice. You cannot build a research station there, and you cannot drop anchor there, because the first storm would have ruined the expedition. That was very depressing at the beginning. We didn't know if we would have been able to carry out the expedition in the first place. These are radar images of ice floes that used radar beams to check the signal that is reflected. It's difficult to interpret, but these are the results. These are ice floe candidates that we looked into when we were there to see if they would be suitable. But after looking at them, and after, well, they all look the same in the radar image, but we noticed that they will all have similar properties. It was one of the warmest summers ever in the Arctic, so we gave up on these ice floes right away. They would have all been the same. This is what it looks like. I think that the batteries in the pointer should be replaced. Maybe that would be a good measure. This is the radar image of the Arctic. Here you see the ice floes. But if you have a look at this particularity, it looks like the others, with one exception. You've got a core which is almost white. And this is something that we looked at more closely, and we came up with a decision very fast. We needed a special floe. We can't use one of the standard floes. We need a very special one, I thought. This is why we went to that floe right away, and we were lucky. This white area is a strongly compressed area. There was a lot of pressure, and the ice floes were shifted on top of each other and froze again, and this gave us the stability that we needed for our ship.
So let's take a look at this in magnification. That's the ice floe with its core in the center. And these are measurements. I'm so sorry. We will really need to change the batteries, or you will have to help me with my slides. Measuring the thickness of the ice that we measured with our electromagnetic measurements. See thicknesses in blue, more than a meter or at around a meter, and everything in another color means that the core is more massive. So the lighter the color, the more the ice would support our equipment. And this is what we built up. This is just a part of what we built up. It's like an artistic illustration of the research city we put on the ice. It was actually a bit bigger, and actually it was pitch dark, pitch black dark, so we couldn't have seen it this way. We had to put together the picture from the individual pictures that we got from our Met City. So this is central Met City here on the right-hand side. This is where we did the atmospheric and physical measurements. There's Balloon Town on the left-hand side, where we had the captive balloon that is able to rise to up to 2 kilometers. And then there's Ocean City for the oceanographic measurements into a depth of up to 4,000 meters. And there was a hole we drilled into the ice, able to give us measurements down to the ocean floor. Then Raft City, where we used our unmanned vehicle to explore the ice from below. And next slide, please. The remote sensing site, which uses the same instruments and tools like satellites in the Earth's orbit. And while we were able to compare the view and to see which tools and which data were related to which quality of the ice, we had our sounding program at the same time going up to an elevation of up to 30 kilometers into the stratosphere, and then to do measurements also from the helicopter. So this is a very comprehensive research infrastructure we put up on the ice. Then we have more ship-based onboard measurements, which were placed in one part of the ship to take a look at the atmosphere. So please take a look at the floor plan. I don't want you to take a look at this in detail. I just want you to see the floor plan of the research camp. This is Polarstern, and the blue is the topographic surfaces. There was a laser scan, and we did a 3D scan from above. So these are all probing areas which we put on the ice's surface. So we have probing sites and sampling sites for sea and ice characteristics, and Ocean City, Route City, remote sensing sites, and Met City are all the stations that we built up on the ice that made up for our research city. And this is just the bird's view perspective. If we take a closer look, then we can see that the research cities taken for themselves are made up of a number of measurement tools. This is a zoom into the Met City area. There's another zoom for the Raft City area, which also held a lot of tools, and also a magnification of the remote sensing site with a lot of instruments, tools placed on the ice. So it's a very comprehensive research infrastructure we placed on top of the ice cap. On top of that, there's a network of met stations around our central research city. This is 50 kilometers away from the ship, and all the triangles, all the blue squares and the green dots, all that is research infrastructure. So that's all devices we place on the ice. Dozens of further met and measurement devices, more than 60 further devices that we formed around Polarstern. And then we started drifting. Take a look at the map. Down here is North Cape, Scandinavia. Here's the Siberian coast with the Severnaya, and then this is our way getting there. This is the shore of the ice layer. This is where we got encased, and this shows the expected ice drifting direction. But of course, after we let the ship be encased, we would just drift with the ice and do what the ice would do. So this is what it looked like. On the first day we came to the floe, the sun even came up, and this was the last day on which we were able to see the sun, after which it set. It's very close to the horizon here already, and then it was gone for the next half year. We were lucky that we did see the sun on the last day before departing. With time, it got darker and darker. Now here the moon is the main light source. Polarstern is firmly encased in the ice. We're building up our infrastructure. Power cables were laid. Actually, we were completely isolated Of course, you can travel from the ISS in space to the Earth's surface in a couple of hours. But here depends on the weather conditions, the time we would have needed to take somebody to hospital in the case of a medical emergency. Usually it can take up to 3 weeks, and with emergency surgery, we could have needed up to 3 weeks to take somebody out of there. So the expedition was completely left to the hands of nature, rather. And we were more than 1,000 kilometers away from the rest of mankind. During the polar night, darkness is a major challenge because anything you do in this impervious darkness of night. And you almost don't see more light than what your lamp on top of your head will emit. And the world has a totally different dimensional structure when all you see is this little bulb of light before you. And if you then see the light of the Polarstern in the distance, and you know that that's where you will survive, then you really feel an emotional attachment with the vessel. Here's the ice sculptures in the ice formed by the wind, this black and white world between the ice that receives some sunlight and then these black areas. I mean, this picture could have been taken on the moon, and this is the way you feel, as if you were out in space. It's a fantastic experience, but it doesn't make working on the ice easier in any way, of course. And then there's the cold. Often there would be temperatures of below -30 degrees or -40 degrees Celsius, and together with a wind chill that takes you to felt temperatures of -60 degrees or below that. And this is temperatures in which you need some protective goggles, and you need to fully cover your face, because unless you do that, your brows will simply freeze. And that's all challenges you need to deal with every day when you live there. So maybe you can move on my slides. And then we would face heavy storms, and we would hardly be able to see anything. There's a snowdrift, as you see it here, and that can get a lot thicker also. And sometimes the ice starts moving and sort of pressure rises and forms ridges. This happens because of the high pressure when the ice floes break in the middle, because they can't withstand the pressure and they shift on top of one another, and they're all moving. And this is where we're eating up our power cables and our sleds. And you can see the sled that was just buried under the ice. And we hurried outside to save what we were able to save, always with a view to maintaining safety, given the very short distances of view in these weather conditions, which is further challenges for work there. Then on the dynamic ice surface, you see cracks in the ice all the time. The ice can just crack for a couple of hundreds of meters, and it's not melted, but it's just simply cracked. Here you can see that one crack has, and one device, Rav City, for example, had moved to 600 meters away, and we're just using the last light of day to bring the station back in and to assemble it in the next place. And this happened over and over again. So that changed the map of our city again. We had to lay power cables again. And then the pressured ice ridges we talked about before, when the pressure in the ice increases too much, and where there used to be only flat ice, and when the pressure increases too much, there's just this bang, the sound, and the ice starts piling up. And you hear these sounds. At times you hear like a squeak that sounds like the crying of a baby or of a young cat. That's when the ice floes move and pile up on top of one another. The ship is pressed into the ice for many, many meters, and you then sense the force of nature that you're totally surrendering to. There's nothing to compare to that. The ice will do to the ship whatever it wants. So these pressured ridges can pile up to 6 meters or so. That's like just 2 houses. Then there's research around the polar bear. polar bears are wonderful, majestic animals. It's wonderful to watch polar bears in their living habitat and how graciously they move. But they're, of course, predators. And you see a hungry polar bear, when it doesn't find seals, can perceive humans as their prey. And this is why accidents can happen with polar bears, and people have in the past been attacked by polar bears and been eaten by them. This is why we need a safety and protection concept with a couple of safety levels, with infrared and warmth cameras, with wires, and with rockets that would go off when a polar bear would hit them, etc. And also polar bear guardians who do nothing but protect the team and stare out in the dark at a little light to find a polar bear on time. So oftentimes that was the case. Polar bears were seen by the guardians, and they had to be scared off using some shock ammunition. So most expedition participants were also trained to use an arm, and all the polar bear guardians have a rifle with them. So quite luckily in our expedition we never had to use it, neither did the Alfred Wegener Institute. So it shows that the polar bear safety concept has always worked.
And we built our research city. Thank you very much for changing the slide. We transported 70 to 100 tons of scientific equipment that we put on the ice, 2 kilometers of power line, and there were more than 100 parameters, climate parameters, that we continuously measured. This is the reason why we were there for in the first place. Now we're going to watch a video. This is a typical scene of a normal day. So this was a scene that will also be shown in the documentary that will be available on the 16th of November. I love this video because it shows a normal day of our expedition during winter. This is how it was done. People are connected via radio. They tell you where they are, and so that we know where people are when, just in case a polar bear appears, and people go out there and do their job in that awkward environment. This was winter. Come March, we had drifted that trajectory. We arrived at the end of March, and the world has been changing. The corona pandemic is hitting us like an ever-destroying weather, and it also affected us because we were an international team and we needed our supply icebreakers to supply us during the expedition. So this was the original plan that I showed you. The first thing that happened, which wasn't that dramatic, the exchange was with Tranitsin was postponed due to bad weather, and we needed the Makarov as an additional ship to supply us with fuel. And now Corona came about. Nothing worked anymore. The ships had to go back to the harbors. They couldn't be deployed. These aircrafts can only start from airfields that are located basically very close to the Arctic. All these airfields were closed. Nobody could go there anymore. The plan of the expedition just fell apart, and we were close to suspending the expedition for good. We couldn't have done so because we couldn't have reached the edge of the ice with our fuel, but we had a time window, a very short time window, to replace something we had planned for years by something completely new. How to be supplied during that second stage of the expedition. And we managed to change plans. If not, in summer we would have to stop the expedition. But we were able to replace it. We had a twin otter supply. Some members of our expedition who, for many different reasons, couldn't stay for much longer, were flown out of the Arctic. If you compare that, phase 3 of the expedition was supposed to end at the end of March, couldn't end. Nobody came to pick up the people except for this very targeted air operation. Apart from that, we extended phase 3 until end of May. The people stayed for 2 more months voluntarily, and then we reduced the subsequent phases from 3 to 2. And then we used the two largest research vessels that became available very fast, and all the milestones that you usually need to plan for the deployment of these vessels were just ignored, and the other institutions that operate these two vessels, amongst them the Ministry of Research, they usually have bureaucratic structures that have to be abided by. They were so reduced that we could reduce them to 2 weeks so that they could support us to replace our team. And our very reliable Russian partners sent us the Tryoshnikov at the beginning of August to proceed with the exchange and the replacements between the 4th and the 5th stage. So our expedition had been saved, and we could continue, but the Maria S. Merian can only operate at the edge of the ice. So this vessel couldn't reach the Polarstern, and this is why we left our position, went to the edge of Spitsbergen. We carried out the rendezvous and went back and started using our camp again and settled on our ice floe for the summer season. The world has changed. It's summer, there's daylight, and we could start with the second phase, the second part of the expedition. This is what it looked like a few days after we came back on the 30th of June. This is our wonderful mosaic floe, which we selected and settled on in October 2019. This is the next summer. This is the ice environment, totally fragmented but our ice floe still exists. But it's summer, the ice is melting, we have melting ponds everywhere on the floe, but we were able to restore the research camp fully, and the ice floe carried the research camp until the end. And the impressions are changing completely on the ice. So the surface is full of melting ponds in many different colors: turquoise, blue, green. More than half of the surface of the ice is no longer white. But there are these ponds, and we have to build bridges to cross. And this is how it looks like when it's sunny, and on rainy days it looks very different. After the winter phase, where I got to know the ice in winter, it looked very differently. There were flags that I were able to recognize, but I couldn't really make the images that I had in my mind match, because the worlds are so different. It's very difficult to compare and to identify what you saw before. The ice in summer is very beautiful. And during that stage, we had many polar bear visitors, very often females with their young ones. They're still very young. Very, very beautiful animals, but careful, because they're going to eat you up. This is our ice floe on 22nd of July, 1 month later, with more melt ponds. You see, this is the Polarstern close to the ice floe. It's still the same floe. The ponds are smaller because the water melted the ice underneath, and the water was drained into the ocean. And the ice is fully fragmented, hardly anything left, but the ice floe is still there. And it carried us all the way to the edge of the ice. When the ice floes come to the end of their lifespan, this is down here. And when it arrived in the open ocean, it broke. They don't break slowly, the ice floes, if they reach the edge of the ice, as I were able to witness on Spitsbergen many times. They just crack. They're intact floes, 4 meters thick on one day, and the next day they crack open and they disintegrate fully. And you have to make sure that you dismantle your camp before that. And we did so. On the 30th of July, very suddenly on the ice floe, these cracks emerged. And this is the 31st of July. This is how it looked like on the 31st. It breaks like porcelain when it falls to the ground. But we had collected everything. Nobody was left on the ice. But we had a very difficult task ahead, and a very important task. When we arrived, everything had been frozen. But now, that was the last piece of the puzzle of the Arctic ice cycle, the annual cycle, the freezing time at the end of the summer. After the summer, in just a few days, due to the position of the sun, the ponds turn into ice, and we wanted to watch that. So we went back north, very far, and one thing which is very unusual, this is a structure we found north of Greenland with a lot of open water, and we went to the North Pole in record time, in just 6 days. Usually there's multi-year ice there. And we exceeded we passed the North Pole. This is how we went there, 87 degrees north, just 300 kilometers away from the North Pole. This is water, all the way to the horizon, 300 kilometers away from the North Pole. This is eroded ice with melt ponds with more holes than a Swiss cheese. And there were large areas of open water. This was really impressive to see how the ice disappears in summer. We passed the North Pole. We looked for a new ice floe. We built a new camp. And this is how it looked like. This is the Polarstern. We again selected a nice piece of ice, a compressed area that we selected. This was ice that was built the year before. The ice was full of and covered with melt ponds. And for that last phase of the expedition, again, we built our camp. And we did so very successfully. This is the 10th of September. A few days later, during that transitory period, this is the freezing stage now. Suddenly all the melt ponds are covered with snow. The surface is much whiter, and this is how it's going to stay for quite a while. This is the last cycle of the annual cycle which we were able to witness. The summer atmosphere in the area is very special, with a lot of foggy atmosphere, very mystic. Here you see the Polarstern in the back. Very often you see this. These are fog arcs. This is 360 degrees of a panorama. Here you see the sun, which is very low on the horizon, and on the opposite side you see the arcs. That's a very mystic atmosphere. The sun is lower and lower, and the colors are increasingly intensive as the sun is setting. And here, this is another phenomenon that you can see very often. These are the halo appearances that you can see. There are lots of ice crystals in the air. This is a phenomenon that you see very frequently in the area. This is the last day on the floe. The sun is fully setting. We're almost at the North Pole at this point in time, just a few dozen kilometers away. The sunset takes 36 hours at the North Pole. You can calculate that. Until the sun has fully disappeared, it takes 36 hours. Nobody ever saw that before. It's the only sunset for a year, and we weren't there either because we had to go back to Bremerhaven 2 days before that, so we could only see how the lower rim of the sun reaches the horizon. We didn't see the full sunset. The next slide, please. During the expedition, we analyzed the Arctic climate, the sea ice and the snow, the formation, the drift and the deformation of the ice, to the eddies in the ocean, the clouds, the atmosphere, the aerosols, the radiation, the interplays, the energy, the momentum and the humidity fluxes from the surface up to the atmosphere, deep into the ocean, and the Arctic ecosystem. The ocean ice is a vibrant ecosystem with many different organisms that are the basis, the food basis for the Arctic system. And we also measured, they release chemical substances that make an impact on the atmosphere, cloud formation, the ozone layer, etc.
So all this really works hand in hand, like the cogs of a very complex mechanism in a wheel. Take a look at this. These coupled processes, dozens of climate-relevant processes, all impact one another mutually, just like the cogs in a wheel. And opening that cogwheel and taking a look at every little cog and to see out of every cog how many teeth it has. This is what we set off for. And if you don't do that, then it's not worth it. It might seem so boring to count all these little dents, but what we wanted to be able to do was to build the mechanics of that cogwheel ourselves, because this complex mechanics of the clock we built, and this is what we need to know every cog for and what it does and how strong it is, and this is what we've done. So next part of the slide, this is part of our data treasure, which holds 150 terabytes of data, which describes all the mechanics and all the systems of this clockwork. We have thousands of samples of atmospheric components, of snow and biological species that we're bringing back to research on in our home labs. And this way we will be able to understand the climate system and to map it precisely in our climate models and not to do any guesswork anymore, because in order to get there you really need to do your measurements and evaluate what we've seen. And in our climate models we will be able to understand how our climate system will be impacted and how it will behave, because this is what we truly need. We need to be able to tell people that if they decide to go for a certain CO2 emission pathway, then that result will be the outcome. And if we take the efforts to come back to a different emission pathway, then the result will be as follows. Only if we understand the results of our decisions in the future today, we are going to be able to make a decision today which will really put climate protection on a sound research-based footing. This is the data treasure we've brought back. But what we're bringing back also is our personal impressions from the Arctic and what we know already. This is what we can talk about right away. The data treasure still has to be unveiled and evaluated, but like temperatures were 10 degrees above the levels Fridtjof Nansen measured. Almost on all days, these temperatures were 10 degrees above that. This fits in with the long-term models we have. We know that winter has increased in temperatures by 4 degrees. And with summer, we saw with our own eyes how the ice is thawing, how it's melting. We know for sure now that Arctic ice will disappear in summertime in future, and this will have major impacts on our climate systems that we cannot even assess fully today. The Arctic doesn't just play a central role in the Earth's climate system, but it's also a vibrant and unique ecosystem. Just like the tropical rainforest, most people are more aware of the fact that the tropical rainforest is an ecosystem of its own, but the Arctic is just the same. This is from microorganisms to small fish to seals and polar bears. All that will disappear once the Arctic ice disappears. Arctic ice is also part of very old cultures and species living there, and the grounds of the livelihoods of indigenous communities living in the Arctic ice. And it's incredibly beautiful. It's incredibly beautiful, and it hurt me to stand there on the ice and to think that my children will not be able to see this in their lifetimes. So we should do whatever we can in the short time that is left to save the Arctic ice. We need to bring down our CO2 emissions comprehensively. Let's make use of this time window we have to preserve the Arctic ice for future generations. Thanks a lot. Questions, ladies and gentlemen? It does not seem to be the case right now. With that, I would like to say kind thank you for your interest, and please bear with us and stay interested in polar research. Thank you.